Hello, everyone. Thank you for joining today's webinar on getting started with PyTecplot. My name is Jared McGarry, the Academic Account Manager here at Tecplot. And my colleague, Brandon Markham, Tecplot 360 Product Owner, is joining me today and will be demonstrating how to get started using PyTecplot and explaining some things to be aware of when beginning your own work with PyTecplot. So first, here's the agenda for today. First, I'll give an introduction of what PyTecplot is for those who may be unfamiliar with it or the tool that it operates, which is Tecplot 360. Next, I'll explain why you should use PyTecplot with Tecplot 360 and show some recent customer examples. Then Brandon will show how to get started using PyTecplot and step through the functions of an example script to illustrate some situations where PyTecplot is particularly powerful. And finally, we will close with any questions that came up during the webinar. So first, what is PyTecplot? Tecplot 360 is our tool for data visualization, and PyTecplot is the Python API to automate and analyze your data with Tecplot 360. So Tecplot 360 has been our flagship software for years and has long been trusted as a multi-purpose post-processor by engineers to remove any doubt in their designs or analyses by providing clear visualization of their complex data. It can create visually impressive 3D plots and also create 2D and XY plots for detailed engineering decision-making. It can efficiently handle large billion-cell data sets for you to visualize your simulated or experimental data from multiple industry standard data formats. And the built-in CFD Analyzer toolkit also gives you the option of performing integrations, extracting key flow features such as vortex cores and shock surfaces, calculating new variables, and more for additional analysis of your data. And PyTecplot allows you to automate all these capabilities in Tecplot 360 with the Python language. Use your own installation of 64-bit Python, install the PyTecplot Python API, and then create scripts that control an active session of Tecplot 360 or run in batch mode, which is especially useful if you want to incorporate this with other Python scripts as part of a larger workflow. So that's what PyTecplot is, but why should you use PyTecplot? Well, first of all, Tecplot 360 is capable of powerful data analysis on its own and has its own custom scripting language known as the Tecplot macro language. However, there's a benefit to using PyTecplot to complement your analysis of data with Tecplot 360. First of all, you can automate your work in Tecplot 360 with a widely used scripting language. So first, actions that are tedious in the Tecplot 360 user interface can be performed quickly with a PyTecplot Python script. And for those who are new to Tecplot 360, the Tecplot macro language does allow you to automate workflows as well. But rather than learning a scripting language specific to Tecplot 360, you can use Python, which is already used for many other tools, and you may have as part of your workflow as well. Secondly, PyTecplot gives you direct access to data for analysis. So there are certain types of data analysis that can be cumbersome or not even possible in either the Tecplot 360 user interface or with the Tecplot macro language. So Python libraries like NumPy or SciPy allow you to analyze and manipulate your data in ways that are not possible using only Tecplot 360. Data arrays, statistical analysis, and easier string processing are just a few examples. Thirdly, you can use your own installation of Python 64-bit. There isn't a separate version of Python that you need to install to use with Tecplot 360 if you already have a 64-bit version of Python 3. And lastly, you can use Python IDEs or integrated development environments for debugging of your PyTecplot scripts. So Tecplot 360 has a built-in debugger for the Tecplot macro language, but with PyTecplot, you can use your own preferred Python IDE to debug your script. So we highly recommend using PyTecplot if you want to get more out of your work with Tecplot 360 and to get to the answers that you need faster. And what we'll show now are some recent applications of PyTecplot from our customers who have already benefited from using PyTecplot in their work. So the image shown at the introduction and repeated here is from Blue Oasis, who are using Tecplot 360 with their renewables and ocean sustainability projects. And the image shown on the left is of a tidal turbine plotted with stream traces and Q factor isosurface. And the animation on the right is a simulation of a free-floating offshore wind platform. So the researchers at Blue Oasis mentioned that the scripting capabilities of PyTecplot provide, quote, a platform for simple scripts that can be executed within the GUI or in batch, which harness the full functionality of the software in streaming complex workflows, saving valuable time in projects. So that's one recent example from one of our customers. Another example comes to us from a customer using Tecplot for Barracuda Virtual Reactor from CPFD software. And what they wanted to understand is where the minimum pressure is throughout the height of their cyclone. So here the contoured slices in each plot display the pressure values along the height of the cyclone. And with just Tecplot 360, you can create a series of slices to visually understand the pressure, but finding the precise location of minimum pressure requires a little more analysis. So because PyTecplot gives direct access to the raw data of the simulation, the minimum pressure location was able to be extracted at defined Z locations within the volume. And then with the set of these XYZ minimum pressure locations, a new zone was generated, which is the line that represents the minimum pressure location as a function of Z, which results in the second plot with a clearer representation of the minimum pressure as that red line along the height of the cyclone. So this example combined Tecplot 360, PyTecplot, and the work of our amazing technical support team to build a custom analysis routine for this data. And this next slide here is just a quick screenshot of where you can find a more detailed explanation of this example. So you can go to the Tecplot GitHub to see a Jupyter notebook that extracts the line of minimum pressure as a function of height. And this is just one among several PyTecplot examples that can be found on our GitHub. So the last example we want to show here is a unique academic application of PyTecplot that comes to us from students at the University of California, Berkeley Multiphysics Simulation and Optimization Lab. And this animation is from the work of Emery Mengi and Roger Iziad, and is the visualization of a ray tracing simulation of an agro-photovoltaic greenhouse. And the purpose of this study was to verify the ray tracing simulation to optimize the geometry and material parameters to design a self-sustaining greenhouse. And they were already using Python for simulation prototyping, and PyTecplot allowed them to integrate time-dependent multiphysics visualizations directly within the simulation. In particular, PyTecplot's ability to accept NumPy data arrays removed the need to format and save datasets. So as a result, they could run variations of the simulation and receive direct visual feedback of the results in Tecplot 360. And the additional benefit of using PyTecplot in their Python workflow is that they could also make use of the animation export options in Tecplot 360 for presentations of their research study. So those are just a few recent examples of our customers who have benefited from using PyTecplot. So now Brandon will get into how you can start using PyTecplot yourself to improve your own work.
All right, thank you, Jared. For the next part, I'll be demonstrating getting up and running with PyTecplot. We'll start from the basics of installing and running some simple scripts, explaining batch versus connected mode while running the Hello World example, and then do a deep dive into a script that highlights many key PyTecplot features. And finally, we'll wrap up by discussing some helpful resources and get into your questions. So we'll first start with the requirements for running PyTecplot, so you can get PyTecplot installed correctly. And Tecplot 360 is required because PyTecplot depends on libraries installed with Tecplot 360, and we'll talk a little bit more about that in this presentation. If you have a portal account already, if you're a customer with us, you can download it directly from that my.tecplot.com website. And if you're not a customer with us, you can also still use PyTecplot and download a version of Tecplot 360 by filling out our free trial there from that link. And also, it's good just to know that it's likely that your organization already has Tecplot 360 downloaded if you do know that you have a license already there. Secondly, we need a 64-bit version of Python 3 installed, which we can access by downloading python.org, downloading a Python 3 installation from there. And then thirdly, now installing the PyTecplot library is really quite simple. So on the command line, type python-m pip install PyTecplot, and that's really as easy as it should be. So you can get more installation instructions on our website in the PyTecplot documentation. We also have options to install from a local source if you don't have access to the internet. And then also, if you don't have administrator privileges, you may also need to include the -- user flag, which I've included on that second line, on that third bullet. So that should give users access that are not administrators. And then fourth, PyTecplot is one of many benefits available under our Tech Plus software maintenance package. You get Tech Plus when you buy a Tecplot 360 license or upgrade maintenance on it. And in addition, Tech Plus also comes with 1 hour of training with one of our team members, which is a prime opportunity to help you customize PyTecplot scripts for your workflows. Let your account manager or support know if you're interested. Now that we've set up PyTecplot, we want to verify that it's installed and working correctly. To do this, we can run a simple run of PyTecplot on a command line without a .py script. So on my Windows machine, I'll demonstrate this. And what I can do is go up here and I will simply type Python. And then I want to just do a really simple test to see if PyTecplot's imported correctly. So I'll do import Tecplot. And then what I'm going to do next is tecplot.new layout. Now, new layout is a simple command that starts up a fresh session of 360 with no data or anything in it. And sometimes it can take a little time as it's loading in the 360 libraries and also acquiring a license. And now at this point, if you got any error on any of these steps, you might have encountered one of the common problems that people can hit if PyTecplot isn't configured just right. And we'll get into some of those details in a couple slides. And my test worked out successfully, and I can just exit out of this for now. And I'll bring this out of view. On the Linux and Mac OS platforms, we want to run Python using the Tech360 environment script. In this example that you see here, I've got the Mac OS path to the Tech360 environment script. As you can see, that applications is in the path. It's a telltale sign we're using Mac OS. But both Mac OS and Linux, this environment script for both of those platforms are located in the bin directory in the Tecplot 360 installation directory. And you can see a part of that path here. And you could do a very similar test on your platforms to make sure PyTecplot's installed correctly. Now, I mentioned the word environment, and what do we mean by that? So, why does that matter when installing PyTecplot and running PyTecplot? We need to remember that PyTecplot requires Tecplot 360 to be installed. PyTecplot isn't just a Python module, it's a Python wrapper on top of Tecplot 360's powerful libraries. And PyTecplot is dependent on these libraries installed with Tecplot 360. In Windows, the libraries are found via the path environment variable. And when using the 360 Windows install wizard, the default option is to add Tecplot 360 to the path environment variable. So it's unlikely that you'll need to manually add the 360 bin to that path. But if Tecplot 360's bin directory is not already in the system's path environment variable, you'll need to add it. On Linux and Mac OS, the Tech360 environment script sets up the appropriate path to the 360 libraries so that PyTecplot can load them. And it's important to use the Tech360 environment script because it directs Python to use the version of 360 associated with that env script. This is particularly important if you have multiple installations of 360 and you want to utilize a specific version. The environment script lets you do that. And then to access a specific version of 360 with Windows, you'll want to make sure the 360 installation of interest is before any other Tecplot 360 installation in the path environment variable. And you can see we're looking at that here. In this example, I'm favoring the beta version of Tecplot 360. If I wanted to use the 2022 R1 version, I need to move that up in my path. And on our next slide, we're going to go over a couple common installation problems. But before we move on, we can just go straight into that. So one of the most common issues users experience is not using the latest version of PyTecplot. For example, Python 3.8 changed the ways that libraries we depend on are loaded. This issue is fixed, but only in PyTecplot 1.1 or later. Older versions of PyTecplot will not work with Python.8 or later. And to upgrade, it's as simple as running pip install -- upgrade PyTecplot. And secondly, we have a significant amount of users running Python via Anaconda. If you do run into issues while running PyTecplot with Anaconda, see one of our KB articles with more information on that topic. You can access it via our website, and I'll just do a quick demonstration of that here. So if I go to the kb.tecplot.com, you can navigate there from tecplot.com just fine. And I could either type in Anaconda here, or just click the PyTecplot category and look through a number of these. And this is the article I'm referring to. Now, you don't really have to look at the details of this right now, but just one thing that I want to note is that PyTecplot is dependent on an external package called Qt, which we use to generate images, and this sometimes conflicts with the version of Qt installed with the base Conda environment. PyTecplot scripts can be run with Anaconda installed after creating a new Conda environment, which does not include Qt dependencies. And also note that Spider users need a standalone installation of Spider if they use it with Conda to avoid Qt issues. That's one thing that we've found in supporting users. And thirdly, if you're on Linux or macOS, but not running using the Tech360 environment script with Python, you might run into a Tecplot library not found error. With the two batch library files names listed below. Try running Python with the Tech360 environment mentioned in the previous slide instead to see if this fixes the issue. It's sometimes possible to get away without using it, but it requires you to set up a number of paths, and they need to be exactly right for your operating system. If you're on Linux or macOS, but not running, if running on Linux configuration with insufficient or no graphics drivers, and you run into crashes when trying to render images, try software rendering, which can be enabled using the following. And I've highlighted that --os Mesa flag there. Now, this is a short-term solution. If you have a graphics card, you should talk to us about troubleshooting the issue. You may need to update your graphics drivers or install a native graphics driver for your system. But if you don't have a graphics drivers at all, this could be your long-term solution. This command will send the OS software rendering command to the Tecplot 360 engine on which PyTecplot is based, and that will help get your script running. For Apple M1 users, if you are installing PyTecplot, our experience is that an Intel version of Python will be required to run your PyTecplot installation. At the time of this recording, we only compile Tecplot 360 and by extension PyTecplot using an Intel compiler. From our testing at this time, PyTecplot isn't compatible with Universal 2 Python, and you'll need to use the Intel version. Okay, and if there's some other issues that you could not find any help with on our website or online, please contact us. This also comes with Tech Plus. We have a talented support team, and we can help you get through whatever issue you might be experiencing. Okay, we've installed PyTecplot. We've verified that it works correctly, and we're ready to run PyTecplot scripts. We'll first examine this code and run a basic script that can be found in the PyTecplot examples directory that comes with your installation of 360. We will call the script the hello world script, and it will run in batch mode for the first run, and then we'll run the script in connected mode after that. We'll ultimately use the script to show the difference between batch and connected mode. But first, let's study the code. So we'll navigate to our Tecplot 360 installation directory, here. And I've already started in the examples directory, but here we're looking at the 2022 R1 installation of Tecplot 360. And then you'll see this PyTecplot folder. There's also an examples folder underneath that. And then we have quite a bit of scripts here, and the hello world is one of them, the first one actually. So I want to take a look at the code here. And you'll see we've imported the Tecplot library in the script, and I've commented out the logging information. This might be helpful if you're trying to debug a little bit, but we don't need to see all this output right now. We also have this new layout command that starts up a fresh session of Tecplot 360. We have a handle to the active frame. Remember that Tecplot 360 has this concept of multiple frames. When you create a new layout, we have one frame created, and we're creating a handle to that frame here. And we're going to add text to that frame called hello world. And then we're going to export an image. And I can see this image in the current working directory. If you can see that when I run the script, that we'll be able to look at it. So let's get a command line up, and I can run this. So I've already navigated to this directory. So I should just be able to type Python and hello world and run this script. And if you hit an error, it might be one of those common problems we discussed. And if you cannot find a workaround, let our support team know. Now, in this first run of the script, we've run in batch mode. And the only way to see your plot is from this exported PNG. So let's go back to this, my current working directory. And you can see here that indeed this image was just modified just now, and we can see that hello world output, that text we put on the plot. And you can run it in, so when we run in batch mode, you can run it unattended. It doesn't need a display if we're not since we're not connected to the Tecplot 360 GUI, and you can run in batch mode on a supercomputer if you wanted. Some of the benefits of running in batch mode is increased performance because you don't need to connect to the Tecplot GUI. And in addition, running in batch mode doesn't eat up a Tecplot 360 GUI license. It's a separate license in your Tecplot license file. Now, if you want to tell the Tecplot 360 GUI what to do and see the plot update, the other way to run PyTecplot scripts is in connected mode. So we'll open up Tecplot 360. I have one right here, and you can see this new layout where we can start fresh. And we'll open up Tecplot 360, go to scripting, PyTecplot connections, and accept connections. And what this is doing is connecting PyTecplot to the Tecplot 360 GUI via socket connection. So it's actually doing a communication between the two applications once I actually run session connect in a PyTecplot script. If you have multiple 360s connected to PyTecplot scripts, you could use the port feature there, but that's unlikely. So let's open up the, let's close this. We'll open up the script contents again. I'll just make this a little bit shorter so we can see more of the plot. And then I also want to bring our command line up, and I'll pull this down so we're not covering up our plot. And let's write Python hello world. I'm just clicking tab to expand that. And then we're going to run with the -c command. And let's run this. So great, we see the hello world shows up on the plot where we've connected to the Tecplot 360 GUI. And running the -c command line argument what happens here is in the if condition, the -c argument will run the session connect function within that if statement. So this is a key function for running in connected mode. And you can see that if the -c is in the set of command line arguments here, then we will connect to Tecplot 360. So in summary, batch mode runs completely unattended and unconnected from the Tecplot 360 GUI. Connected mode connects to and controls the 360 GUI, but that comes at a performance cost. And in this next slide, before we move on from this Hello World example, I want to show an example of running PyTecplot in a Jupyter notebook. So I've got my Jupyter notebook running here, and I've already installed it on my machine. And then what I want to do, so I just want to show this example of running PyTecplot in a Jupyter notebook, because running PyTecplot script in environments like these, or some other favorite Python IDE that you might have, can make writing, debugging, and executing your scripts easier and less error prone. We'll take a look at the Hello World script in this context. And Jupyter notebooks pull up the Jupyter notebook in the browser. And what I've done is just copied the code from the Hello World script, pasted it in here, and this is all the same Python code. And one of the strengths of Jupyter notebooks is that you can run certain parts of your code separately, and then you can also show visuals of your plot without being in connected mode with this ipython.show function, which you can see the output here below that. And PyTecplot is integratable with other IDEs, just whatever you prefer with writing your Python scripts in. And now, at this point, we have the basics down on how to run PyTecplot scripts. Next, we'll explore a more complicated example. And in this time step delta script, we'll cover creating simple functions, using equation in loops, pulling data from the data set, altering it with Python, and then stuffing it back into the data set. We'll cover the session suspend context, talk more about that. Tecplot 360 has this concept of multiple frames, and we'll create a multiple frame layout. And then we'll also discuss the differences between macro, execute command, and Python functions. And finally, we'll go over iterating over solution times. We'll hit many of the highlights of the Python API in this script. And before we really dive into the code, what I want to do is just show the results of the script that I've run earlier. And that's what I have in this window. So what this script does is it takes a transient data set where we have a transient flow around a cylinder. And we want to know the change that is happening in the pressure variable from one time step to the next. In this case, we're going to be computing the delta between the current time step here and the time step before it. So the time step here. You can see we have two frames. This top frame is showing that solution in the current time step. The bottom frame is showing the delta in pressure from the current solution time and the previous solution time. So this is the current one, and this delta is this current time, solution time pressure values minus the pressure values that we see here. And then this plot here is this current solution time subtracted by this current solution time, and so on and so forth. So we will now, this is a pretty complicated task in Tecplot 360. You can't do it in the GUI, so we'll need to do this with the PyTecplot script. And now we can look at the script itself here. So I'll pull up the script. I already have it loaded in my text editor, and we'll make this window a little bit bigger. We're not going to go too deep into the details here, but we want to explain and understand the different sections of the script. We can see that this script imports a few libraries, and that's going it's going to use at the top of the script here. In the if statement down below here, we can see that we pass -c on the command line. We're going to connect to the GUI, and if not, we'll run in batch mode as we discussed earlier in this video. We'll skip over this next function and discuss it further later. And so as I scroll down here, you can see that we have this new layout function that we've seen before. We're starting a fresh session of 360, and then we're going to be loading in these next 3 lines. These are used to load a data file from the Tecplot 360 examples directory. And you can see that we load this data file with Tecplot data.load Tecplot right here. And just a note, all these commands can be found within our PyTecplot documentation, and it's pretty easy to find them. And I'll just show really quick here how to do that. So if I'm in the PyTecplot documentation, this can be accessed in the documentation on tecplot.com, and it's also located in the installation directory of Tecplot 360. And let's say I want to learn a little bit more about that function. So I can type it into the search and search it. We see it's the first search result. And if you have any customizations, any particular parameters that you need for using this function, you can see and learn more about your options here. And then let's go back to the script, and we'll move on to this next section. So here you can see in the section below, we're putting all of these commands within a session suspend context. This is particularly helpful in connected mode because it increases performance by preventing the UI from continually updating the plot as the script runs. And we'll take a look here at line 56. We're defining which variable or variables we're going to do this calculation for. Then we are looping over the zones, all the zones. So we want to do a different calculation from your first time step. We're actually not looping over all the zones. We're stepping back from the total number of zones -1. So because of this calculation, this delta calculation that we're doing. And then what this is doing here is what we talked about before. So it's doing the difference calculation between the first time step or zone in your and your second time step zone, and then it goes from the second to the third, and so on and so forth. On each loop, we use this calculate delta function that we'll look at later, and we calculate the delta between the current zone Z and then add 1 to get to the next zone. Notice that it's referencing zones by zone number. We use zone.data and input the zone number to get the zone object here. Now, once this calculation is complete, we'll get down to this section of the code. And we're going to do a bunch of plot style setup in the frame and plot commands below. And we'll talk about frame 1 first. So we've already have one frame in the data set from creating that new session of Tecplot 360 with the new layout. So we're going to get a handle to this first frame. Next, we're going to get a handle to, we're going to create a second frame and then get a handle to it and make sure that the second frame is in the 2D Cartesian plot type here, just like the first frame. Then we'll tile these frames vertically, which creates the equally sized and spaced frames that we saw before. And I want to ensure that before I start changing style for frame one, I want to make sure it's updated, or I might not actually be changing the style for frame one. And in this first frame, all we want to do is make sure that the first frame shows the contour layer, which you see here, and also the pressure contour variable, so that we can see the nice solution contour plot in the first frame. This was the top one that we were looking at earlier. And additionally, I want to set up frame linking between my two plots. And note that here we have linking between the solution time here. So you saw when I moved from one solution time to the next, both of the frames updated, and that's because they are linked by solution time. And then you can also see the x-axis and y-axis are linked as well. And so if I change the view on the top one, if this x-axis changes, the viewport on the bottom frame, its x-axis will also change in the same way. And then also note that this is written in our macro language as a string currently within the macro.execute command function here. So to alter these commands, you need to do string editing, which isn't ideal. So we've added the majority of Tecplot 360 functions as PyTecplot commands and functions, but there are still some that aren't added, and they'll show up in recordings in PyTecplot scripts here and there, and they'll look something similar to this. Note that we do actually have these examples that I'm talking about, the linking between frames, added as PyTecplot commands, but we wanted to keep this execute macro command as an example. So now that frame one is set up, we'll move to frame two, which is the delta plot frame. We want to activate this frame and make sure any of the commands we have below are applying to that frame. And then we're going to get a handle to the plot of frame two here. And just note that all of these parameters associated with this are going to be parameters for the Cartesian 2D plot type. Again, we're making sure that a contouring variable is set here, and notice that we're setting this to the delta variable that we've computed. Again, I haven't talked about the compute delta function yet, but we'll get there. And make sure the contour layer is on for frame two. And then we set the contour layer levels and the color map as well for this plot. Then we're also setting the plot axes, x-min, and min-maxes, and also the y-min maxes. Then down towards the bottom of this script, we'll be exporting only a few solution times for the sake of performance. If I remove this, what I could do is just, I could cut that out. That would then iterate over all of the solution times. And that's most of the time, that's probably what you want to do. But for this demonstration, we just want to limit the amount of time this script takes to run. So I'll keep this in here. And then, at the very bottom, you'll see that we have a command to save our work as a new data file here. And what we're doing up above that is that we only want to save out the pressure, the Cartesian variables, and then also the pressure and pressure delta variable to be included in this file. So the script is pretty simple, but it doesn't take a long time to run. But if you're doing lots of time-consuming calculations, you might want to save your data and pick up from that point. In addition, this data file is smaller than the original one since we only exported the variables that we needed. Okay, so let's go back up here and talk a little bit more about this calculate delta function. Again, we wrote this loop, the zone loop here, and put the calculate delta function inside of it, which takes the variable or variables that we input to it along with the current zone and the next zone. And note, we chose to reference our variables by name, but we could reference them by number too, and vice versa with the zones. We could refer to the zones by name, but we reference them by number instead. Let's go up to the definition of the function and note that we've shown two different ways to calculate this. There's two different methods that we could use to calculate the delta within this function. Now, we'll first come through and loop over all the variables in the variable list. In this case, we've only supplied one variable, so it's only going to go through this loop once. We're creating a new variable if one doesn't exist here, and then we're also going to so with that new variable, if we're going to use that original variable name and then append delta to it. And then next in here, we'll show you two different ways to calculate the delta. And the first method that we're going to talk about is via data alter equation. What we're doing here is computing a new variable by subtracting the variable values of the current time step from the variable values of the previous time step. Then we execute the equation here. We print it out as well before that. And the advantage of this approach is that we are executing this equation in the Tecplot 360 engine. So all the data stays within the Tecplot 360 engine. And this is going to be the fastest way to do this data alter. Tecplot 360's equation processing is fully multi-threaded, so it can distribute the calculations over multiple processors. But for this smaller data set, it's not going to make much of a difference. And as the script is written, this is the default calculation. You can see use equations is true. And then the other method for doing this is to do this calculation actually with Python down below here. The reason we wanted to show you this is that it reveals the power of using PyTecplot, and because it gives you access to the raw data. So in this function, we're getting all the data values for this specific variable here as an array. So we're pulling all of these values out of the Tecplot 360 engine, and we're storing it in this variable z1 vals for the first zone. Then we do a similar action below for the second zone. Next, we compute the delta and stuff those values back into Tecplot 360. And then this delta is calculated using NumPy array arithmetic to do the math to create a new array of values. And then we tell Tecplot to stuff those values back into the Tecplot 360 engine. So this power of PyTecplot opens up all sorts of doors for analyzing your data. We're calculating deltas here, but you could fill in the blank with any analysis or calculations you'd like to do. And to run this method, we need to run the script with use equations equal to false here. I would change true to false. But so just to recap on the script, we've shown you how to loop over a series of zones, and we've shown how to set up PyTecplot style down below here in the frame and plot commands, where we've shown how to export images down below here, and also to save data here. And we've shown you two different methods of doing this, this calculation that we want to do in the script. So now let's run the script in connected mode, and we'll use We'll keep the use equations as true here, and I'll run the script with the -o flag as it optimizes the run, and I'll get to that soon here. So let's go back to this installation of Tecplot 360. I'll click the new layout. I don't have to because we remember that is already in our script, but I will just double check our PyTecplot connections. Great, it's still connected from that last time we ran the hello world script. And I want to go here this time, since we're in this file is located in a different location. And we'll type Python and then the time step delta. And I actually want to run Python with this -o flag to optimize this run of the script, and it helps it run a little bit faster. And then we also want to run in with the -c command, and I'll click enter. And particularly in connected mode, the script will run faster using the Tecplot 260 data alter equations rather than the Python method we talked about earlier. This is because in connected mode, we're connected to the GUI via sockets, and all that data needs to be transferred out of 360 and back in as big arrays via these sockets, and this takes time. It took about twice as long to calculate via the Python method rather than the 360 equations method mentioned in the connected mode on my machine. So you see, this looks great. The plot showed up as expected. We have our solution time, and then the delta is calculated, and those frames are linked, and this is what we want. And so before we move into questions for the webinar, I want to highlight two more helpful tips for getting started with PyTecplot. So let's get back to the PowerPoint, and I want to talk about recording scripts first. So PyTecplot recordings are crucial to make PyTecplot scripts. Recordings are the building blocks to getting your PyTecplot script created. If there is a feature you want to script in PyTecplot, go to scripting, record PyTecplot, and save a recording. Then as it's recording, go through a few GUI features. After you click stop recording, the PyTecplot equivalents of the action will be saved. I'd recommend this as a starting point for writing your script, and then look up the documentation from there. And then secondly, we have a number of resources I want to point your attention to, which can be found on our website, tecplot.com. We've mentioned this a couple times here today, but the PyTecplot documentation is a crucial resource to get your code to do exactly what you want it to do. We have helpful information from installation, example scripts, and function definitions on this website. And then another super helpful resource is our PyTecplot. Well, and then it's also really helpful to search in here too. But we also have PyTecplot videos, which are also very helpful, and they cover, there's other getting started with PyTecplot videos there too that offer different content and also more specified videos that you can learn more nuanced features, and in particular using PyTecplot. And then we can go and look at, check out some of our blogs and articles on PyTecplot. This one is particularly helpful in getting started. And then also see our GitHub for examples of handy scripts we've created and we've gathered from other users. We have a Jupyter notebooks here, as Jared mentioned, and he gave a quick snapshot of one, and also a variety of Python scripts. In particular, you might be interested in our data conversion scripts that you can find within the Python directory here. And that concludes the presentation for today. So now we'll get into answering the questions that have come in, and we can wait a little bit for some of your questions. It looks like we have a couple right now, so we'll just take a look at that.
Yeah, thank you, Brandon. And just a reminder for the attendees here, you can still enter questions into that question field for GoToWebinar. while we're still here. But if you have questions afterward, you can email us at support@tecplot.com or support-eu@tecplot.com if you're in Europe or Western Asia. Yeah, we have a question that came that's kind of a request as well. It's asking, will you write a short knowledge base entry on using PyTecplot on Linux systems, which usually install Spyder, SPYDER, using Anaconda? It was briefly mentioned that Spyder needs to be installed in standalone mode. Are there any more caveats? So do you know if that knowledge base article we have about Anaconda and PyTecplot addresses that, Brandon, or are there any other articles that might address that, installing Spyder using Anaconda with PyTecplot?
We don't have ones particularly for Spyder that I know of. It's come up from a couple of support cases, that point that I mentioned, but that's helpful to know that we have some more questions on that topic, so we can prioritize that more and dig into it a little bit deeper. We'd love to talk more too after this webinar and maybe understand your experience a little bit more too.
Okay, yeah. So for that user, thank you for that question and request. We'll take that into consideration. We may follow up with you after the webinar to get a little more info, because that is helpful to us to know about these different situations that Python users may run into.
Yeah, but I don't have expert advice on Spyder at this moment.
Okay. Yeah, we have another question. Yes, saying that we mentioned we can install Python libraries such as PyTecplot without internet access. How do we go about doing this? Is this something I can find in the knowledge base articles? And I think this is covered in the PyTecplot documentation, which also comes with the Tecplot 360 install. Is that correct, Brandon?
Yeah, that's correct. So I'll just go to the index of the PyTecplot installation. So let's say if we were on Linux here, the section you'd want to look at is installing from local source, and you can get some more information here on that. So you should also note that there might be a couple more libraries you would need to install manually as well, such as some of these for if you want to run in connected mode. We rely on those. So it's definitely more complex installing offline, but it's possible. And then I see another question here. Is it possible to write a PyTecplot macro which enables the PyTecplot session connect? I believe that it is possible. I think what might need to happen is you may need to alter your Tecplot configuration file. I don't remember that script right off the top of my head, but we can get back to you over email with some more specifics. But you can, I would check our scripting guide in particular for that one.
And then we have another question asking, is there a Tecplot macro converter to PyTecplot? So there is, through PyTecplot, you can call the macro language, but this may be asking if there is a script that converts a macro, Tecplot macro, into a PyTecplot Python script. Do we have anything like that, Brandon?
That's a good question. What you can do is put macros into that execute macro command. You can put a number of them in, I believe. I don't think right off the top of my head here that you can run a macro, for instance, and then be recording a PyTecplot session. I think that's a feature request that we have, so that's what I would know. I would say just at this moment in time, I would need to dig into that maybe a little bit more.
Yeah. So if you have a Tecplot macro script, Brandon, if you show that, if you show the time delta example script, and you can see there's the portion in the sort of orange font, that's calling the macro language within this PyTecplot script. So if you do have a macro, Tecplot macro language script, you could have a PyTecplot script that calls the entire content of the Tecplot macro script within your Python script. And so that's where you can start with, but then you'd want to convert some of those commands, if not all of those commands, into Python. And if you haven't used PyTecplot or Tecplot 360 and you want to get started, go to tecplot.com and you can start a free 5-day evaluation from our website. And that way you can start using for your own work right now. And it looks like as I was saying that, I've got a question asking how long until Mac M1 support?
Yeah, so just to clarify, Mac M1 machines do work with Tecplot 360 just fine. I have a M1 Max that I'm using right now that I run Tecplot 360 on, but the thing is it just runs in emulation mode, so it doesn't run natively. And it's also possible to run PyTecplot scripts on these Macs too. I do it almost every day, but we just don't run them natively is the key. So we're looking at doing that, in the next year or so. We need to investigate a couple different options to do that, but currently you should still be able to use Tecplot 360 with M1 machines.
Yeah, it looks like that's it for now. So again, you can ask us after the webinar. We'll get back to you on those. And for those of you who ask some of the questions that are a little more involved, we'll follow up with you to help address your questions and requests that you brought up. But thanks everyone for attending today. Thank you, Brandon, for going through that great demonstration of getting started with PyTecplot and that really useful time average script to show some of the interesting capabilities. Hopefully this is useful for everyone. And like I said, if you want to get started right now, if you haven't already started using PyTecplot or Tecplot 360, you can start a free 5-day evaluation from our website and get started with your own work today. So thanks again, everyone, for attending, and bye for now.